In this video, we will continue practicing writing the equation and graphing the equation of a hyperbola. Looking at example 2, we want to write an equation for the hyperbola with foci at 0, 7 and 0, negative 7, and vertices at 0, 6 and 0, negative 6. When they just give you pieces of information like this, the first thing you should do is to draw a diagram. So let's see, if the foci are at 0, 7 and 0, negative 7. Alright, so that means we have a focus here and we have a focus here. We have vertices at 0, 6 and 0, negative 6. That means we have a vertex here and we have a vertex there. Now the branches of a hyperbola wrap around each focus. So we know we are dealing with a hyperbola that is vertical. It's opening up and it's opening down. The fact that this is a vertical hyperbola means that the y term of the equation is going to be in the front. So I know I'm going to have something with a y in the front. We can also tell what the center is going to be, because right in the middle between these two vertices should be the center. So this problem will be easy because the center is 0, 0. That means my numerators will just be y squared and x squared. And it's always equal to 1. Again, we knew y squared would be first, the positive term, because it is vertical. So all we need are the denominators. We need a squared and we need b squared. Well, we already know what a is going to be, because a is the distance from the center to a vertex. So this is a right here. A is 6. That means a squared is going to be 36. So the a squared always goes in the first fraction, the positive one. So this will definitely be the 36. Now, finding b is going to take an extra step. Because we have the a value, and indirectly we have the c value also. The c value is the distance from the center to a focus. So we know that the c value is 7. Which means that c squared is 49. So we have a squared and we have c squared. So let's talk about b squared. Remember that for hyperbolas, the formula relating a, b, and c is c squared is equal to a squared plus b squared, unlike ellipses where it's a minus. So substituting in c squared and a squared, we have 49 is equal to 36 plus b squared. Now, subtracting 36 from both sides, we see that b squared is 13. We don't need to take the square root because we actually want b squared. So we'll just go ahead and put the 13. So this will be the equation. So what was that again? We had y squared over 36 minus x squared over 13 equals 1. Example 3. Find the equations of the asymptotes and the coordinates of the vertices for each one of these. Again, I would recommend drawing a diagram. The first thing we need to do, other than knowing that, of course, the center is going to be 0, 0, which we know because we just have x squared and y squared. Other than that, we need to figure out what's a and b. So for a hyperbola, it doesn't matter which one is bigger. The first denominator is always going to be a squared. So a squared is 16. That means that a is 4. Notice that 16 is in the y term. That means when I do my plus and minus 4, I'm going to do it in the y direction. So I'm going to do plus and minus 4 in the y direction. And these will be my vertices. All right, the a value will always give you your vertices. Okay, so my vertices are here. Now let's find the co-vertices. Okay, so the 36 is b squared. That means that b is equal to 6. Since the 36 is in the x term, I will do this plus and minus 6 in the x direction. So these will be my co-vertices. Now my vertices and my co-vertices are going to give me a rectangle. So let's draw the rectangle that's defined by these vertices and co-vertices. All right, draw the rectangle as a dotted line. The rectangle is important because the asymptotes are going to be formed by the diagonals of this rectangle. So look at these corners. So this diagonal line is going to be one of my asymptotes. And this will be the other asymptote. Remember, these pink dots are the vertices. So the branches are here. All right, now let's look back at what they asked us to find. We're supposed to find the equations of the asymptotes and the coordinates of the vertices. So we already found the vertices. So let's write that down. Did they give us any blanks or anything? No. So the coordinates of the vertices will just be 0, 4 and 0, -4. Now, what about the equation of the asymptotes? Well, I like to use point-slope form for the equation of a line. So remember that point-slope form works like this. In general, we do y minus y1 is equal to the slope times x minus x1, where m is the slope and x1 and y1, that's a point on the line. The easiest thing for you to do is to use the center of the hyperbola as your point. So since the center is 0, 0, that means we're putting in 0 for y and 0 for x. So that's going to simplify this equation a lot. Now all we need is the slope. For the slope, you can really look at the rectangle very easily. Look at this portion of the asymptote. What is the rise and what is the run? Rise over run. Well, it's up 4 and over 6. Okay, so my slope is 4 over 6, which reduces down to 2 over 3. So that's why the equation of the asymptote, don't forget, because of the zeros, I just have y equals, and then the 2/3 and then x. We will put a plus or minus on here because there are two asymptotes, one positive and one negative. So this is the equation of both asymptotes. Let's move on to part B. Again, we know that the center of the hyperbola is going to be 0, 0 because we just see x squared and y squared. So let's go ahead and graph that. All right, the center is right here. I'm marking it even though the center is not a point that's on the hyperbola. So there's the center. Now we need the a value. The a value will lead us to the vertices, and we know that a squared is always going to be the denominator of the positive term, the one that should be first in standard form. So that means that a is 4. So notice that the 16 is with the x term. That's why when I do my plus and minus 4, I will do it in the x direction. So I'm going to go plus and minus 4 in the x direction to the left and to the right. And again, these are my vertices. And I believe that's one of the things that we were asked to find, are the vertices. So we can write that down right now. Okay, so the vertices are negative 4, 0 and 4, 0. Okay, now let's keep going and find the co-vertices because we will need those to be able to find the asymptotes. So the denominator of the negative term is going to be b squared. So this is b squared. So that we know that b is going to be 5. Notice that the 25 is with the y term. So when I do my plus or minus 5, I will do that in the y direction. Okay, so this is a co-vertex and this is a co-vertex. They did not ask us to list the co-vertices, but they did ask us for the asymptotes. And the vertices and the co-vertices define a rectangle that we need to draw, which will reveal the asymptotes. So use your vertices and your co-vertices to draw a rectangle as a dotted line like this. Because the diagonals of the rectangle, the line through those diagonals, are the asymptotes. So I'm going to have an upward leaning asymptote, an asymptote with a positive slope that's going to go like this. Okay, that's an asymptote. And then we'll have an asymptote with a negative slope that goes like this. So those are the asymptotes. Now, I need the equations of those two lines that I just drew. So again, I like to use point slope form. That looks like this. Y minus y1 is equal to the slope times x minus x1, where the x1 and y1 represents a point on the line. Now, for asymptotes, the easiest thing to do is to use the center, because the center of the hyperbola will always be on both asymptotes. So with that in mind, the equation becomes y minus k is equal to, and I'll go ahead and say plus or minus the slope times x minus h, because h and k are the coordinates of the center. And I'm doing plus and minus because the slope of the asymptotes are the same for hyperbolas, except for one is positive and one is negative. So basically, you can use this as the formula for hyperbola asymptotes from now on. And h and k are the coordinates of the center that we are used to dealing with. So using the 0, 0 for the h and the k, all right, so k is 0 and h is 0. And all we need is the slope. So the slope is really easy because we're just talking about rise over run. So consider this portion of the asymptote. What's the rise and run? Well, it's up 5 and over 4. Okay, so the rise and run, that's 5 and 4. So that's the slope, is 5 over 4. So the equation becomes, well, y minus 0 is just y. So y is equal to plus or minus 5 over 4. And then since the h is 0, I'm just going to have x. So that's it. These are the equations of both asymptotes. And that's it. They did not ask us to draw the actual hyperbola, but I thought I'd follow through and notice we could have drawn the hyperbola, and if we did, the branches would have been approaching these asymptotes on either side. We knew from the beginning that these were the vertices, so of course the branches would be here and here. But one more thing, always keep in mind that if the x term is first, then the hyperbola will be horizontal, opening left and right. Or I could say it's a horizontal transverse axis, remembering that the transverse axis is the segment connecting the vertices. So that's going to be horizontal when the x term is first. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.